So you'll notice in our algorithm it says to manipulate one or both equations in order to perform the elimination method. Example 12, this is going to be an example of a time when we need to manipulate both equations instead of just the first. So we'll start with step one. Step one says write everything in standard form. It looks like equation 1 is already written in standard form, but equation 2 is not. Let's go ahead and fix that. So equation 1 doesn't need to be changed. It's just 5r minus 3s is equal to 24. Equation 2, well, we need to clean that up a little bit. Let's move this 3r to the other side by adding 3r. So I will add 3r. That gives me 3r plus 5s is equal to 28. Next, I want to decide who am I going to eliminate. And my candidate here, the one I notice, is s. I have a negative 3s here and a positive 5s there. The signs are already opposites of one another, so all I need to do is fix that number so that they're the same. I'm going to ask, okay, is there anything I can multiply 3 by to turn it into 5? Well, yes, but unfortunately that would be a fraction. And I'm trying to avoid fractions whenever possible. So let's look at 5. Is there anything I can multiply 5 by to turn it into 3? Again, not without introducing fractions. So instead, what I'm going to look at is the least common multiple. If I can find the least common multiple of 3 and 5, I can use that. We write that as LCM 3, 5 if you do any computer programming. And since 3 and 5 are both prime, in fact, the least common multiple will simply be their product. So it's 15. All right, let's see. What do I need to multiply 3 by to turn that into a 15? How about 5? And multiply equation 1 by 5. Five times 5, 25. And 5 times 3 is 15, is negative. And I divide by 24, giving me 120. This gives me a new equation. I'll call it number 3. And I'm going to do the same thing to equation 2. What do I need to multiply 5 by to turn it into 15? No, 3. So I will multiply all of equation 2 by 3. That gives me 3 times 3, 9r. 3 times 5, 15, of course, by design. And then 3 times 28 gives me 84. And I'll just call this equation 4. So what I'm going to do is now do the elimination adding step using equation 3 and equation 4. So I will take 25r minus 15s equals 120 and add to that 9r plus 15s equals 84. This gives me 34r plus 0 equals 204. My next step says, okay, solve what remains. All I need to do here is divide by 34. And I'll take 204, divide by 34, that is 6. The next step says, all right, if r is 6, take that back to one of our original equations, plug it in, and find out what s is. I'll go to the original equation 2. Notice it was written as 5s equals 28. minus 3r. That's very nearly solved for s, so that's a little less work for us. I'll put in 6 for r. I'll have that in that 28 minus 3 times 6 is 18. Is 5s. 28 minus 18 is 10. And finally, I simply divide by 5, and I get s is 2. Last thing, I'll just take my proposed solutions and check them in the original system. My original system was 5r minus 3s equals 24. And 5s is equal to 28 minus 3r. Now we already know that 6 and 2 work in this equation because that's how we found the 2 in the first place. So we'll check here. Check in the first equation. R is 6, S is 2, and we hope this comes out to be 24. 5 times 6 is 30, and 3 times 2 is 6. And actually, yes, so 30 minus 6 is 24. So I can write that my solution is r equals 6 and s equals 2. If you want to write that as an ordered pair, r comes before s in the alphabet, so I will write it as 6, 2.